The CRRC Qihang 20 megawatts floating offshore typhoon-resistant wind turbine. As the world confronts the escalating threats of climate change, renewable energy technologies must not only deliver clean power but also withstand increasingly severe weather events. In this context, the CRRC Qihang 20 megawatts floating offshore wind turbine, developed by China's CRRC Corporation Limited, emerges as a groundbreaking achievement. This turbine combines unprecedented power output with advanced typhoon-resistant engineering, setting a new standard for resilience in offshore wind energy. By addressing both energy efficiency and climate adaptability, the Chihong turbine represents a pivotal step toward a sustainable and secure energy future. Offshore wind energy has long been hailed as a cornerstone of decarbonization, offering vast energy potential far from terrestrial constraints. However, traditional offshore turbines face vulnerabilities in regions prone to typhoons, hurricanes, and cyclones, storms that are growing in intensity due to warming ocean temperatures. China, with its extensive coastline and frequent exposure to Pacific typhoons, has taken a pioneering role in developing solutions to this challenge. The Qihang turbine, unveiled in 2023, embodies this vision, a floating wind platform capable of generating massive amounts of electricity while enduring extreme meteorological conditions. The Qihang turbine boasts a rated capacity of 20 megawatts, MW, making it the most powerful floating offshore wind turbine globally. To contextualize this, earlier generations of fixed-bottom offshore turbines typically operated at 5 to 8 megawatts, while even cutting-edge models rarely exceed 15 megawatts. A single Qihang unit can power over 35,000 households annually, significantly boosting energy output per installation. Mounted on a semi-submersible or tension leg floating foundation, the turbine operates in water depths exceeding 50 meters, where fixed-bottom structures are impractical. This design allows deployment in deeper seas, accessing stronger and more consistent winds while minimizing visual and acoustic impacts on coastal communities. The turbine's defining feature is its typhoon-resistant architecture, engineered to survive sustained winds exceeding 17 on the Beaufort scale, over 220 km per hour, equivalent to Category 5 hurricane force. Key innovations include reinforced composite blades. Constructed from carbon fiber reinforced polymers, the blades are both lightweight and ultra-durable, designed to flex under stress without fracturing. Dynamic yaw and pitch systems. Advanced sensors and hydraulics enable rapid blade feathering and nacelle rotation to align with wind direction, reducing lateral forces during storms. Smart survival mode. During extreme weather, the turbine automatically enters a low-risk configuration, locking the rotor and disconnecting non-critical components to minimize damage. High-strength mooring systems. Multi-point anchoring with corrosion-resistant alloys ensures stability against violent wave action and shifting currents. Integrated digital monitoring. Real-time data analytics and remote diagnostics allow operators to preemptively adjust settings or initiate shutdown protocols. By harnessing deep-sea wind resources, the Qihang turbine accelerates the transition away from fossil fuels. A single 20 megawatts turbine avoids approximately 56,000 tons of CO2 emissions annually, contributing to China's goal of achieving carbon neutrality by 2060. Its offshore location further mitigates land use conflicts and preserves terrestrial ecosystems. The turbine's large capacity reduces the levelized cost of energy, LCOE, by leveraging economies of scale. Fewer turbines are needed to generate equivalent power, lowering installation, maintenance, and grid connection expenses. Additionally, its typhoon-resistant design minimizes downtime and repair costs, a critical factor in regions where storm damage previously posed significant financial risks. China's leadership in offshore wind technology is underscored by the Qihang project. As the world's largest installer of offshore wind capacity, the nation now leads in climate-adaptive energy infrastructure. This positions China as a key exporter of green technology, particularly for countries in the Asia-Pacific region and Gulf Coast, where typhoon and hurricane risks hinder renewable development. For nations like Japan, the Philippines, and Vietnam, the Qihang model offers a blueprint for deploying offshore wind without compromising safety. Similarly, Caribbean and Atlantic-facing countries could adopt similar designs to combat hurricane threats. International collaboration on typhoon-proof turbines may drive down costs globally, accelerating the adoption of floating wind farms. The CRRC Qihang 20 megawatts turbine exemplifies the fusion of ambition and engineering ingenuity. In an era defined by climate volatility, it demonstrates that renewable energy systems can be both powerful and resilient. By proving that floating wind farms can endure nature's fiercest tempests, The Qihang sets a global benchmark, not merely for technical prowess, but for humanity's capacity to adapt and thrive in a changing world. As typhoon-resistant turbines like the Qihang proliferate, they will play a vital role in securing a cleaner, safer, and storm-ready energy future.